Okay, hi everyone. So now we are going to enter ratio of three or more quantities. All right. So these are things that we have already learned in primary school. So I won't elaborate too much, and we'll just like see whatever comes, and we'll just tackle it. Okay. And the first thing that we're going to do is question one in practice now six. We have two separate ratios, x to y and y to z, and we want to get these two ratios together. So let's observe that over here the y would be the common quantity. So how do we make them the same? So how do we make them the same? We will try to make y the same, and once we make y the same, we can combine them together. So let's take a look over here. We have x to y, right, is 5 to 6, and then we have y to z is 4 to 9. Okay, so the thing is, because we are looking for y, so this number over here and this number over here will play a matter. We want to merge both ratios together, means that we need to make them to have the same parts. And for them to have the same parts, we will need to multiply by their LCM. Okay, so over here, we need to multiply the oh no, sorry, need to not multiply, we need to change, right, the common variable to the LCM. So the LCM of 6 and 4 is going to give us 12, right? So how do we get 12 over here? So if I want this to be 12, 6 times 2 is 12, 5 times 2 will give me 10. Okay, we will need to make it equivalent. Next, 4, to make it 12, I need to multiply by 3. So 9 times 3 will give me 27. Okay, we see. So we can combine them together now. So x is to y is to z would be 10 parts to 12 parts to 27 parts. Okay, so once more, the skill over here is to change common variable to LCM, and we will merge both separate ratios together as one. Now let's look at question 2. Question 2, we are looking for the ratio of 600 meters to 0.9 km to 30,000 cm. Okay, so what we have here is are three separate quantities with totally different units, right? In order to get them to ratio and in order to get them to simplify nicely, we will need to convert them into common what do you call this, common units. So what common units is suitable? I think let's look for the middle ground between kilometer, meter, and centimeter. Let's convert them to meters, right? So 600 meters would be just 600 meters. 0.9 km. Kilometers is long. So let's take a look at this one over here. So kilometers to meters, we multiply by 1000. Meters to cm, we multiply by 100. Okay, the other way one would be divide. So 0.9 km times 1000 would give me 900 km. Now 30,000 cm. Now let's take cm over here, divide by 100. We're going to get 300. Oh, sorry. It's going to give me meters, right? So 900 meters, 300 meters. So we can drop the meters because now all the units are the same, and we can now, unfortunately, we can't do the calculation like the calculator method like we did in the earlier ratios. So we have to fall back to our basic knowledge on how to simplify ratio, which is to multiply or divide by a common number. So over here we can divide by 100. So let's have 6 to 9 is to 3. And just nice, we can divide all by 3. So we will get 2 parts to 3 parts to 1. Okay, so the final answer will be 2 to 3 to 1. Okay, so the what do you call this? The technique again, right, is to change to the same unit. Okay, very, very important. For ratios, we must change them to the same units. Actually, not just ratio, but a lot of the scientific quantities, we have to change them to the same units. Okay. Now let's jump right into the next word problem over here. We have a sum of money divided among Raju, Albert, and Vani in the ratio of 6 to 4 to 5. After Raju gives $30 to Albert and $15 to Vani, the ratio now becomes 7 to 6 to 7. Find the amount of money Raju had at first. So this is a before and after question. So let's set up before. Let's set up after. Right, so before and after, we have Raju to Albert to Vani. Right, we have these three people, so they are in the ratio of 6 to 4 to 5. The next one would be 7 to 6 to 7. Okay, so now the thing is to look for any similarity. So the thing is that Raju gave money, Albert received money, Vani received money, so these three quantities will not be the same. However, there is one quantity that can be the same because the money is not lost to some random person. The money is still within the pool. It's just circulated between the three of them. So actually the total amount of money is actually the same. So let's find the how many parts do we have for the total. Okay, so over here the total parts 6 plus 4 plus 5, this would be 15 parts. The other side 7 plus 6 plus 7, this would be 40. Also this would be 20 parts. Okay, so this would be 20 parts. Now, so what we have is that 15 and 20, let's make them the same so that we can keep track on the changes of each quantity. Okay, so over here, what is the LCM of 15 and 20? We can make it, okay, 30, maybe not 45, 60. So let's make it to 60. So 15 times 4 is going to give me 60. So I need to multiply everything by 4. So I have 24, 16, 20, and 60. Right, you see? 60 over here. So everything multiplied by 4. Now for the 20, we are going to multiply everything by 3 to give me 60. So 7 will become 21. This will be 18. It will be 21 again. And it will be 60. Right, so the total is going to be 60. Okay, so let me box these two things. Okay, so the thinking is we need to make total the same. Okay, because the total is unchanged. So the thing is that we need to make the quantity that does not change the same so that afterwards we can keep track of the changes. So let's take a look at what changes do we have here. We have Raju 24 units and after is 21 units, so he gave away 3 units. So we can see that Albert received 16 to 18, so it means he received 2 units. Vani received 1 unit. Okay, so Raju gave $30 to Albert. So $30 to Albert means that over here, these 2 units would be equals to $30. Do you see that? Okay, so 2 units. Okay, wait, sorry, the transfer. Okay, let me look for the transfer. Right, so no, let me write the transfer then. Okay, transfer. So 2 units, right, would be $30. So one unit is $15, right? So if you want to use the Vani one, okay, so 1 unit is $15. So find the amount of money that Raju had at first. We are going to look for 24 units. Okay, so over here 24 units would be $15 multiplied by 24. So this would give me $360. Okay, so Raju had $360 initially. Okay, so once again, I hope the strategy is clear. We try to make something the same and then we'll track the total or we'll track the difference. Okay, or we look at the transfer. Okay, so this is one very common strategy that we have for ratio. Okay, so of course there's going to be an algebra working, but the algebra working, I think I will leave it for you to try if you're keen on your own, because I think it's not worth like doing that sort of problem unless they ask you to form equations. Then that's another thing. But I think for ratio questions, like most of the time we are more keen in terms of doing it with numbers like what we did in primary school. Okay, so let's move on to practice now 8. So in practice now 8, wow, long question. Page 44, Li Ting wants to buy 500 ml bottles of concentrated washing detergent, right? And the suggestion is going to be a mixing ratio of 1 part to 4 parts. Okay, so 1 part of detergent to 4 parts of water. So if Li Ting needs to make 5 liters of washing solution, find the number of bottles of concentrated washing detergent she has to buy. So she wants 5 liters of washing solution. Okay, so let's form our ratio first. We have detergent, we have water, and we are going to look for the total. Okay, so detergent 1 part, water 4 part, total is going to be 5 part solution. So Li Ting wants to make 5 liters of washing solution, means that the total amount of solution, which is 5 units, would be 5 liters. Okay, so we are looking for the amount of detergent that she has to buy. She has to buy 1 parts, so 1 unit would be just dividing by 5, so she just needs 1 liter of bottle. Okay, so this means that Li Ting needs 2 bottles of detergent because each bottle is 500 ml. Okay, so this is first part. Second part is that using the number of bottles bought in part 1, Li Ting decides to make a more diluted washing solution than suggested. If she makes 10 liters of washing solution, what is the mixing ratio that she uses instead? So let's take a look over here. We have detergent, we have water, we have the total again. Okay, and okay, so over here, for the detergent, I have 1 liter. Okay, I have 1 liter of detergent. I don't know the don't know the amount of water, but I know that the total solution is going to be 10 liters. So knowing this fact, right? So how much water do I need? I would definitely need 9 liters. So this is us filling in the blank, 9 liters. Okay, so the mixing ratio that we need, right? The mixing ratio that we need over here, right, would be 1:9. Okay, instead of 1:4, now we can make it 1:9. Okay, so I hope this exercise is a good revision for your primary school knowledge. We will not dwell on this too much. We'll focus on a bit more advanced questions that will be coming up in the upcoming parts. So stay tuned, right? We keep this in our minds. We try to remember what we did in primary school, but at the same time, we will need to make use of some of these concepts in the future topics, in the future parts of this chapter. Okay, so that's all. Hope you can catch the next video or the next lesson, and see you soon. Bye.